Hi, welcome back to the vlogs.
Okay.
I know you missed me.
9.4. We're going to talk about polygons and their angles. Okay. I have 12 slides, but honestly, a lot of it is like pictures and diagrams and just looking at some things. Okay. Polygons and their interior angles. Okay. Interior angles inside a polygon. This polygon happens to be a pentagon. It has 5 sides. Okay. 5-sided polygon pentagon. Okay. In order to figure out what the sum of the interior angles are, these are my interior angles, angle, 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 okay? If it is a polygon that's a regular polygon, that means that everything is congruent, okay? All the side lengths of each and all the angles of the interior angles are congruent, okay? So to find it, you're going to take the sum of the angles.
Interruption. Jillian Miller, please come to the front office. Jillian Miller to the front office.
Uh-huh.
I have my, sorry.
Okay, we'll take
That's my 9.2.
Okay. So in order to find it, we are going to use a formula that they're going to give us. And I think I have it on the next slide. I'm going to check. Give me a second. Anyhow, this formula, okay, we'll talk about the formula and we'll look at other ones. This formula tells us in order to find the interior angles, okay, we're going to take the sum equals 180 degrees. 180 degrees times the number of sides minus 2. So how many sides does this figure have? 5, right? So 5 minus 2 is 3. And then I take 3 and I multiply it by 180 and I get 540. Okay? So on this one, I would get that the sum of all these angles would be 540. How can I figure out what each angle is then? What each interior angle is? If I know that the interior angles add to be 540, you just divide it by 5. So I would take 540 divided by 5, and that's how I get that each interior angle is 108. Okay? So to find the interior angles, this is for interior.
Does that say n minus z or minus 2?
Minus 2.
Meters.
Yes.
I'm going down to the gym.
Okay. So to find the interior angles, you take the sum of the interior angles equals 180 degrees times n minus 2, times the number of sides minus 2. So if I have a figure that is 7 sides, what am I going to do to figure it out? Multiply 180 by 5, and then I'm going to take that and divide it by 7 to figure out each interior angle. Okay? Not hard. Very simple, as long as you know that formula.
Does it get harder from here?
No, there's lots of easy formulas today. Okay, so here is a 6-sided polygon. Okay, so I take 6 minus 2, which is 4. 4 times 180, which is what?
Wait, why would you do 4 times 180?
Because the formula tells me it's the sum of the interior angles equals 180 times the number of sides minus 2. If I have 6 sides minus 2, I get 4. So 4 times 180 should give me 720. Okay? And then I'm going to take 720, what am I going to do with it? To figure out each interior angle. Divided by 6. So each interior angle should be 120 degrees, which is what they have marked. 120, 120, 120, 120, 120, 120.
So what would they be asking?
They would be asking, what is the measure of an interior angle of this object? Or they will ask, what is the sum of the interior angles? If it's the sum, I don't have to go back and divide by 6. Okay? If it's what is an individual interior angle, I have to go back and divide by 6. Make sense? Okay. So here is an example. Formula for the sum of interior angles. Once again, it's a pentagon. Okay? So we already know the answer to this. But how would I set it up? What would I do to figure out? It says formula for the sum of interior angles is n equals the number of sides. Sum is 180, n minus 2. Let's say you have a dodecagon. Who knows how many? Okay. So 10. So what would be the sum of my interior angles then? 1,000 what?
440.
440, because you do 8 times 180. Now, what would be one of the interior angles? 144. Okay? Can you handle doing that? Okay? Okay? Now, here's why this works. Okay? Each triangle has how many total, or how much does each triangle add to be angle-wise? 180. Okay? When I have a pentagon, look, I can divide it up into 1, 2, 3 triangles. That's why I do 5 minus 2. Because I get 3 triangles when I have a pentagon. And that means I have 3 sets of 180 degrees. That's why on any shape that you do, that's how many triangles you have inside of that shape when you subtract 2 from it. So if I have a 12-sided figure, I have 10 triangles in that figure. That's how they come up with that formula. Does that make sense? Okay? And so that's why we can do things the way we're doing them. Because it breaks into triangles, all the shapes do. I know, you're thrilled, I can tell. Okay? So it says the measure of an angle in a regular polygon, okay? They want to know what is the measure of one of the interior angles in this. How can I figure that out? How many sides does this have? 8. Okay, so what are you going to do? Yep, 8 minus 2 times 180. So what's 180 times 6? 1,080. Okay, but it just wants one interior angle, so what do you have to do with that? Divided by 8. What's 1,080 divided by 8? 135 degrees. So if you have an octagon, each interior angle is 135. Okay? Pretty simple? Okay, because we're going to, later on in this chapter, use this information so that when we split those angles, we'll know that it's half of 135 so that we can solve using sine, cosine, and tangent. Okay. Okay, a regular polygon means that all sides are congruent, all interior angles are congruent. If you have a regular polygon in directions, if it says, you have a regular polygon, tell me the measure of the interior angles. All the interior angles are congruent, all sides are congruent. If they say, here's a regular polygon, one side length is 6, what's the rest of the side lengths? You would say 6, okay? Regular means side lengths and interior angles are congruent. Okay? The other type of polygons that we can have are irregular polygons, and that means things are just not congruent. So it would have to label it for us or give us more information. Okay? So, you can have 2 other types of polygons. So polygons are classified by regular, irregular, and they're classified by convex and concave. Okay? Concave is easy. It caves in at some point. Okay? Convex is just a normal shape. So this is a convex polygon. This is a concave because I've got this dip in there. Okay? I think it's easy to remember because it sounds like it, right? Like it kind of collapses in a little bit, okay? So when you're classifying polygons, you're going to tell me, are they regular and convex, regular and concave? Are they irregular and convex? Are they irregular and concave? You're going to give me 2 descriptions, okay? Here we go. It says, using interior angles, what is the measure of angle F? Okay. Now, tell me how I can figure this out. Do I have all the other interior angles? Yes. Okay, good. I have all the other interior angles. What? Uh-huh. From what? Okay, it's 180 times n minus 2, right? What? How many numbers of sides do I have? 1, 2, 3, 4, 5, 6, 7. Okay? Yeah, so you were right. I'm going to add up all those other interior angles and subtract it from what I'm supposed to have total interiorly. And I made up a word, I think. Okay. So, what should I have interior? What should the sum be interior? The sum equals,
Wait, did you say interior?
yeah. The sum equals 180, 7 minus 2, right?
Yes.
7 minus 2 is 5. What's 180 times 5?
It is a word.
Okay,
900.
it's 900.
Are you sure?
Yeah.
Okay. 900 degrees is what I should have on the inside. So let's add, what's 110 plus 200? 310. What's 310 plus 110? 420. What's 420 plus 110? 530. And what's 530 plus 150? 680. And then 680 plus 90. Because that's a right angle. 770, so then subtract 900 minus 770. $130. So the measure of angle F equals 130 degrees. Can you handle doing that?
Is that all we're doing?
Well, we're gonna
Right.
do one other thing. We're gonna do exterior angles next.
Okay.
Okay, but exterior angles I think are even easier. Okay, because remember how I told you every shape can fit in a circle? So what do you think the measure of the exterior angles are gonna? Okay. Using interior angles. Now, here's a way they might give you a problem too. This doesn't have a picture, so you have to think. Okay? A polygon's interior angles sum to 1080. What type of polygon is it? So I can classify the type if I work this problem backwards. Does that make sense? Okay? So my sum is 1080. So I'm going to say 1080 equals what? 180 times n minus 2. Okay? How do I get n by itself? What do I need to do first?
Divide by 180.
Yeah, divide by 180. What's 1080 divided by 180? 6. And then I add 2, right? So you get 8 sides, which is what type of, and that's what they want you to do.
So we just say it's an octagon?
They want you to say it's an octagon, but I need you to show me work behind it.
Oh, okay.
Okay? Make sense? Okay, pretty simple. So we can work the problem both ways. We can find what the interior angles add to be, and then we can use that information also to find what each interior angle is, if it is a regular polygon, or even if it isn't a regular polygon, because they'll give me enough information. And then if they give me how much the interiors add to be, I can work it backwards to figure out how many sides there are to tell you what type of figure it is. Okay? Okay, exterior angles of a convex polygon. Convex means what?
It's like, the all is regular.
Yeah, it looks like a regular shape. They don't go in, okay? Exterior angles of a convex polygon. Exterior angle, an angle formed by side of a convex polygon and the extension of its adjacent side. So what happens is this. Let's say you have a pentagon, right? Like this. I'm just gonna make it like a house shape. What they're saying is this extends out, so it's this angle here. Okay? This one also extends out, so it's this angle here. You get what I'm saying? So there's a lot that I can do. They're saying the extension of that to the outside of that polygon creates a exterior angle. Okay? And it's the same thing if it's convex. It's the extension of that exterior angle, okay? They're both the extensions. Give you a second and then I'll switch slides. We got 2 more. So like I said, it wasn't a lot. It just seems like a lot with the number of slides. Charlie, you good? Okay. So exterior angles of a convex polygon. Here's where a polygon is. The sum of the exterior angles of a polygon is equal to 360 degrees, period. Okay, period. No matter if it's an octagon or a hexagon or a quadrilateral, the exterior angles add to be 360. Okay? So here's the deal. If it is a regular pentagon, that means all sides are equal, all interior angles are equal. It also means that the exterior angles are then going to be equal. So I would take 360 and I would divide it by 5 to figure out what each of those exterior angles are. Does that make sense? Okay? So when you have exterior angles, they always add to be 360 because I can inscribe that shape inside of a circle. So here, okay, it says, what is the measure of BX or BCX? So I'm looking for BCX, BCX. I'm looking for this right here. Okay, this is my unknown. How can I figure out what that angle is? Okay, what?
You gotta add all the other ones up
Uh-huh.
and then subtract it by 360.
Beautiful. So I'm going to add 56, 102, 67, 48, and subtract it from 360. So it should say 360 minus, and then I'm going to put in parentheses all my work I'm doing. 56 plus 48,
67.
and then 102. Okay? So if I do that, I can solve for x equals x. So I'm going to do 102 plus 56 plus 48 plus 67, and you should get 273, yeah? So 360 minus 273 equals x, so x is going to equal 87 degrees. So the measure of angle BCX equals 87 degrees. Make sense? Okay, that's exactly what's on your homework today. That stuff right there.
Can I stop the vlog?
Yep, stop it.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Bryson?
Hey, I will give you a hint on